While planets are often the focus of attention in schools and space agencies, there are lesser-known worlds within our solar system that are equally fascinating. Among these are the Galilean moons, Jupiter's 4 largest moons. Despite their proximity to each other, these moons are remarkably distinct. They include a volcanic moon, a moon with one of the highest chances of supporting life, the largest moon in the solar system, and an ancient scarred moon whose surface dates back to the solar system's early days. I'm Alex Mullen, and you're watching Aram. In this video, we'll explore these extraordinary moons one by one, diving deep into what makes each so unique. By the end of this video, you'll understand why they are the focus of upcoming missions from both NASA and ESA this decade. Let's begin with Io, the innermost of these moons. Io, the volcanic moon. Io is one of the most intriguing objects in our solar system. As the closest of Jupiter's large moons, it stands out for its unique features, including active volcanoes, auroras, and a sulfur-rich atmosphere. To fully appreciate Io's characteristics, let's take a closer look at its context. Io orbits just 350,000 kilometers above Jupiter's cloud tops. From Io's surface, Jupiter would appear over 40 times larger in the sky than our moon does from Earth. Io completes its orbit in just 42.5 hours, a stark contrast to our moon's monthly orbit. The gravitational interactions between Jupiter and Io create tidal bulges on Io's surface that can reach up to 100 meters. This is significantly more dramatic than the 2-meter tidal variations caused by our moon on Earth. Jupiter's immense gravitational pull, combined with the gravitational influences of the other large moons, ensures that Io's orbit remains elliptical. As a result, Io experiences constant tidal heating, which prevents any respite from this gravitational tug-of-war. Interestingly, a day on Io is equivalent to its orbital period, meaning it is tidally locked to Jupiter. Just as we always see one face of the moon from Earth, only one side of Io is ever visible from Jupiter. Io is comparable in size to Earth's moon, with a similar density, giving it comparable gravity. However, Io has the highest density of any moon in the solar system. Unlike most large moons, which are composed of water, ice, and silicates, Io is primarily made of silicate rock and iron, much like the terrestrial planets. It also has the least amount of water of any known body in the solar system. Io's core is likely composed of iron or iron sulfides, surrounded by a silicate-rich mantle and crust. However, its core is thought to lack convection, as Io does not have a detectable magnetosphere. Volcanic activity on Io. Io's most fascinating feature is its volcanic activity. The moon's surface is dotted with hundreds of massive volcanoes. Before the 1970s, little was known about Io. Early telescopic observations suggested it was waterless and possibly covered in sulfur. NASA's Pioneer 11 mission provided the first close-up views of Io, revealing that it was made of silicate rock rather than water ice and had a thin atmosphere. However, the mission was hindered by Jupiter's intense radiation, which disrupted its onboard systems. The Voyager missions in 1979 offered groundbreaking insights into Io. Voyager 1 flew within 20,000 kilometers of Io's surface and captured stunning close-up images. These revealed a vibrant, colorful landscape with no impact craters, towering mountains higher than Everest, and vast volcanic pits. Voyager 1 also observed active plumes rising from the surface, confirming that Io is volcanically active, the only known place beyond Earth where such activity has been directly observed, excluding cryovolcanism. Voyager 2, though farther away, confirmed the persistence of volcanic activity on Io, observing 7 of the 9 plumes seen by Voyager 1 4 months earlier. These findings suggested continuous volcanic activity. The Galileo spacecraft, which arrived at Jupiter in 1995, provided even more detailed images of Io. Although the spacecraft experienced mechanical issues, it captured some of the highest resolution images of Io's surface. These images revealed plumes from multiple volcanoes and confirmed the presence of sulfur and silicate magma, similar to what is found on Earth. On Earth, Io's magma contains an unusually high concentration of magnesium. The outer layer of Io is strikingly vivid, with yellow fields primarily composed of sulfur. The white regions consist mainly of fresh sulfur dioxide ices, especially near the poles. Radiation alters the sulfur at the poles, giving them a redder appearance compared to other areas. In certain spots, the red hues result from deposits left by volcanic eruptions that have reached hundreds of kilometers above the surface. The most notable deposit comes from the now dormant volcano Pele. When Galileo passed nearby, Explorer 1 captured a massive plume from this volcano, standing 300 kilometers tall and 1,200 kilometers wide, roughly the size of Alaska. Interestingly, magma flows on Earth typically emerge from depressions at volcano summits, but this is not the case on Io. Instead, Io features vast magma lakes with high external walls. One of the largest volcanic depressions, 200 kilometers in diameter, directly connects to the subsurface magma supply but is often covered by a thin solid crust. Loki, one of Io's most active volcanoes, accounts for 25% of the Moon's heat output under normal conditions. Occasionally, the crust sinks back into the magma, causing Loki to release up to 10 times its usual heat. This phenomenon is also observed at other volcanoes, such as Tvashtar, where the crust collapses into the magma lake, creating intense thermal energy. In 2007, the New Horizons spacecraft used Jupiter's gravity to slingshot toward Pluto, taking the opportunity to observe Io during its flyby. The data revealed stunning volcanic activity, including a massive eruption at Tvashtar with a plume extending kilometers above Io's surface, as well as smaller eruptions scattered across the Moon. Io's volcanoes are relatively flat, but it also has some of the tallest mountains in the solar system, with peaks reaching up to 18 kilometers in height. These mountains are typically isolated rather than part of ridges or ranges. While most are not volcanic, magma lakes are often found nearby due to weaknesses in the crust. Another fascinating aspect of Io is its interaction with Jupiter's magnetic field, one of the largest and strongest in the solar system. Io orbits within the most intense part of this field, and particles from its thin atmosphere and volcanic eruptions escape into space, forming a neutral cloud around Jupiter. This cloud extends far beyond Io's orbit, and a donut-shaped plasma torus of ionized particles surrounds Jupiter. The plasma rotates at 70 kilometers per second, much faster than Io's orbital speed of 17 kilometers per second, creating significant electromagnetic friction. This generates a current of approximately 5 million amps between Io and Jupiter, making Io the most powerful electrical conductor in the solar system. When this current reaches Jupiter's atmosphere, it creates intense auroras, even more dramatic than those on Earth. Io itself displays auroras along its poles. Io's atmosphere is extremely thin and primarily composed of sulfur dioxide. Its temperature varies widely. In Jupiter's shadow, the atmosphere can collapse and snow onto the surface, while areas near active volcanoes can reach 700 degrees Celsius. In contrast, other regions may dip as low as -150 degrees Celsius. The side of Io facing Jupiter has a denser atmosphere, sometimes resulting in immense atmospheric cascades onto the surface. These conditions make studying Io's atmosphere challenging, but observations from the Galileo spacecraft and Hubble Space Telescope have provided valuable insights. Despite its extreme features, Io is a moon of contrasts. It boasts both the hottest and coldest temperatures, the highest mountains, and the flattest volcanoes in the solar system. Its dynamic volcanic activity is driven by tidal forces from Jupiter, which also generate the strongest electromagnetic field of any known object. Ongoing missions like NASA's Juno spacecraft, which is currently orbiting Jupiter, are expected to capture even closer views of Io in 2023 and 2024. Io's uniqueness makes it a priority for future exploration, but it is not the only intriguing moon in the Jovian system. Europa, for example, has a smooth, icy surface believed to hide an ocean containing more water than all of Earth's oceans combined, making it a prime candidate in the search for extraterrestrial life. Callisto, the most heavily cratered object in the solar system, and Ganymede, the largest moon with its own magnetic field, are also thought to harbor subsurface oceans. NASA's Europa Clipper mission, set to launch in 2024, will conduct detailed studies of Europa's icy shell and potential subsurface ocean. Similarly, the European Space Agency's Jupiter Icy Moons Explorer (JUICE) mission, launched in 2022, is set to study Ganymede, Callisto, and Europa in detail. These missions aim to uncover critical information about these moons' conditions, potential habitability, and the processes that have shaped our solar system.